So direct comparison will be a lot easier to explain than integral test, and won't take 13 minutes. So let's say k is just a finite number. We know that it's finite. We know we could count to it if we were given enough time. And the idea is that k might be the value of a series we know converges. So c, we have another value. It's a value in question. We don't know whether it could be the sum of a series. We don't know whether it converges or diverges. So c is just a value. We don't know if it's an infinite or a finite value. So if and only if c is less than k, then c is finite. That is actually not true. I am stupid. This should just be if. So if c is less than k, then c must be finite. But if and only if c is greater than some infinite value, then c is infinity. This should be pretty intuitive, right? Like, if I have 2 and I subtract 1, there's no possible way. Well, this will obviously be less than 2, right? And 2 minus 1, there is no possible way this can equal infinity. If you can, go get a Nobel Prize, but I don't think you can prove this, right? That 2 minus 1 equals infinity. And the other idea is that if you've ever been on a middle school playground, you'll know that, infinity plus 1 is bigger than infinity, but it's still infinity. It's still an infinite value. It's infinity, right? So now that you can analyze that, it's pretty easy to do direct comparison. Let's call this one C, because this is a hard thing to evaluate by itself. Just note that n over 2n plus 1 will always be less than 1 for n equals 1 to n equals infinity. For those whole numbers, since 2n plus 1 will always be bigger than n. Just understand that this is less than 1. And if you multiply something by a value that's less than 1, it'll be less than that. So a is always less than or equal to b for any value or any sum. So that's our value in question. This is k. Through geometric series, you can pretty easily confirm that this converges. I don't think I have proved it yet, and I don't feel like proving it in this video. I might show it in the geometric series video. I'm still not sure if I'll do a full proof of the test or if I'll just explain the sums. But, this is a convergent value. This is k, a finite number. So if we know that b is always bigger, then k must be greater than or equal to c. And if this is true, this is a finite number. If you did the math, you'd get like, I don't feel like doing the math actually. You get some finite number, so let's just pretend that it's a value. I don't feel like doing math, so I'm going to say, what's your favorite number? I'll go with 9. Right, so if there's some value less than 9, it's not going to be infinity. It cannot be infinity. Infinity is not less than 9. So, C must converge. And the opposite is true, right? If I have these series, n, starting at n equals 0, and this one starting at n equals 0 to infinity, n plus 1, since this is infinity, this will just be infinity plus some number, which could also be infinity. This will also be an infinite sum, since it's bigger than this one, and this one is infinity. Should be pretty clear that, I'm sorry my handwriting at the end was messy, but direct comparison is really intuitive. Just, if something's bigger than infinity, it is also infinity. If something is less than not infinity, it is also not infinity.